Welcome to the Case for Conservation podcast. I'm your host, Andre Mada. I keep meaning and forgetting to thank everyone who downloads and subscribes to this podcast. Your interest is the reason why I do this, and your downloads are the main indication of interest in the project. So thank you very much to the hundreds of listeners in now more than 40 countries who are supporting this endeavor. If you feel so inclined, please also rate the podcast and comment if you have any improvements to suggest, or future topics or future guests or whatever else. I'll soon provide contact details on the website for those who would prefer to write me directly, rather than commenting on the site or on various podcasting platforms. Today's episode is about Indigenous and local knowledge, or traditional ecological knowledge. ILK, or TEK, is becoming increasingly respected and accepted as relevant knowledge of the status and trends in nature, as presented in international biodiversity assessments. I think this is a very good thing, but I have the impression that ILK may be accepted unconditionally in some cases, whereas science is meant to be vetted by a process of peer review. Now, that's not to say that the scientific literature is infallible or immune to bias, but the system of peer review is set up to challenge existing ideas. Science is also, at least in theory, more connected and unified and universalized through processes like the scientific method and peer review, whereas ILK or TEK is generated in multiple localities, most of which are disconnected and quite distant from one another. Zsolt Molnár is a botanist and ethnobiologist who has spent many years working with local knowledge holders, especially herders and mountain farmers, and has played a central role in bringing Indigenous and local knowledge into the assessments of the Intergovernmental Platform on Biodiversity and Ecosystem Services, or IPBES. In the discussion that follows, he helps me to unpack some of the questions that I have about ILK, and we talk about its relationship with scientific knowledge. Let me start off by asking how you became interested in conservation and how you ended up pursuing a career in conservation.
I was born in Hungary, in Western Hungary, in a small town, and my father was a forest engineer. My mother is a teacher. So what I remember from my early childhood is that we went for excursions every weekend. So the city is next to a wooded area, and my parents loved spending several hours a week with the family in nature. So what I remember that I was picking flowers, mushrooms. My father told me that none of them is edible. And, after 2 years, one was edible or two was edible. And then I realized that I learned from my father the birds, the trees. So I became interested very much in nature in general. Then in a secondary school, I had very good teachers. And one of the teachers was the guy who wrote the first book in Hungary on threatened plant species, István Csapody. And going to the field with a professor who is very much interested in conservation and good teachers in the secondary school, I ended up going into the direction of biology and ecology. I was also very much keen on bird watching. And bird watcher is a person who visits the field every week from January till December. So I became interested in how nature changes, how nature works. And because we lived close to a city, probably I experienced early in my lifetime the destruction of humans, but also the cultural landscape, because we lived in a cultural landscape where humans not only destroyed nature, but also contributed to it. We had a sweet chestnut forest. And, even in the school, that was a communistic area in the early and late 80s in Hungary. So even during the so-called agricultural works we did in the school, about 2 weeks each year, we went to a sweet chestnut forest collecting sweet chestnut. So all my secondary school years were spent with close contact with nature. We also had gardens, fruit gardens, vegetable gardens. So I was born into love nature and be in nature. And during the university years, my interest focused more and more in ecology and conservation biology, because my teacher at the university was one of the first conservation biologists in Hungary. So these were the drivers of my early life towards conservation and conservation biology.
And then from university, what was your career trajectory up until where you are now?
I graduated in 1990, which is the time of the revolutions in our countries. So life changed very much in 1990s. I became an adult, a husband. We moved from socialism into capitalism, and the opportunities arrived to go to the West to visit universities and research institutions. So I spent a year in Nottingham in central England and learned a lot about conservation ecology and especially landscape history. So in the first 15 years of my scientific career, I was mostly interested in landscape ecology and historical landscape ecology. So how landscapes and the vegetation changed in the last 200, 300 years in Hungary, in the lowland, in the Hungarian Great Plain. And in England, I learned lots of methods how to approach the history of a landscape, how to read landscapes using old documents, old maps, and oral memories of locals. And you know, I mentioned that that life changed in Hungary, which means that the maps became freely available. And because Hungary was part of the Austrian-Hungarian monarchy, we had a map for the late 18th century at a scale of 1 to 28,000, which is an extremely detailed map. And with my wife, Mariana Biro, we made a vegetation reconstruction of the Hungarian Great Plain for the late 18th century. And we realized that how much landscapes changed. And fortunately, we had a botanist living exactly in those decades who had a more than 1,000 page long botanical diary. So we had the maps, detailed maps, and we had the botanist who traveled along these roads and described the flora and vegetation of the area. So this strengthened my understanding why conservation is important, because I realized that there are processes in the landscape, and some processes are unexpectedly fast, and some processes are unexpectedly slow, which means that if you want to protect the vegetation heritage of an area, you have to work with processes that have different speed. And you know, our lifetime is usually shorter to understand the differences in the speed of these ecological processes. So historical landscape ecology helped me to understand what is stable in the landscape, what is transitional, what is degrading, what is regenerating. So all these complexities of changes were decoded from these historical sources. And that was a really nice period in my life, full of stories of people lived long ago and transformed the landscape for this or that reason. And they wished for a change in the landscape, which happened or not later. So all these actually stories, stories of a landscape were very, very interesting.
And then your interest and your work on local communities in particular, how did that develop? I mean, you've already given some pretty strong clues, but was that something that you were involved with right from the start, or how did that come about?
Yeah, that's an interesting story, because it came from an illness. I had ambrosia allergy, Ambrosia artemisifolia, ragweed. And when I had this allergy, I couldn't work in my study area in August and September. So about 1/3 of the field season was cut. And by that time, we already had 2 children. So what do you do with 2 children and with a ragweed allergy and not much money? So we went to do some ecotourism, was called at that time. So we went into Transylvania and spent 4, 5, 6 weeks in villages with the family. And the vegetation of those regions differed so much from the lowlands, so I didn't know most of the plants. In the lowland, I walked and I knew all the species, all the plant species, but not here in the mountains. And I started to speak with locals. We joined them for grazing, herding, haymaking, mushroom collection. And I realized that they know much more about the species and the habitats or the ecology of the landscape than I expected or I learned from universities. This was one driver of my change in interest. The other was that we visited so-called tradition homeschool or heritage summer schools where Hungarian folk tales were taught and handcrafts. I played the Hungarian wooden shepherd flute. And we listened to lots of lectures on why traditions are important. But I realized that those people who are teaching about traditions are mostly social scientists or teachers, language teachers, history teachers, and they knew very little about the ecology behind these traditions. And I get a bit frustrated that those traditions must have some ecological background because they are so different between mountains, hills, and lowlands. So I started to be interested in what is the ecology behind the culture. And the third driver was, if we go back to my landscape historical work, that I became interested in what those people knew about the landscapes, who changed the landscape, who drove changes in the landscapes, what understanding they had about ecological processes, how they wanted to change successional pathways. So these 3 drivers led me into the topic of traditional ecological knowledge or indigenous and local knowledge. And at that time, we had a huge project on mapping the habitats of Hungary. So for about 6 years, I actually had this traditional knowledge as a hobby because my main job was mapping the Hungarian vegetation heritage with 200 people, 6 years. So I had no time to focus on this research, which actually turned out to be very helpful because it was a long ripening phase how to do this research. And because I had no time to read international literature on traditional ecological knowledge, we developed our own way to work with these people and to learn from these people, because every summer we went to Transylvania for weeks. So the approach towards traditional knowledge was ongoing while the research on traditional knowledge was not yet started. I was not pressed by any project. I was not pressed by my institute to do research on traditional knowledge, but we were slowly born into the topic. And it was by 2008 when we really started to do this research and started to visit international conferences, and we started to read literature on ethnobiology and traditional ecological knowledge.
And then your focus zoomed in more on that particular aspect of your field, I suppose.
Yeah, so there are different directions in ethnobiology in the research of traditional knowledge. One is more psychological, anthropological, how people classify species, ecosystems. And there's another direction, how they manage the natural resources, which is closer to the conservation biological understanding of nature. So we did both. So we made thorough case studies on which species are recognized by local people, how they name it, what ecology they know about the species. We were interested very much in how many habitat types they distinguish. And with my colleague Daniel Babai in the Eastern Carpathians, we worked in a village where people distinguish more than 148 habitat types in a single valley, which is the highest ever found in the world, because Daniel was working for years to elicit the habitat knowledge of these people. So this was more ethnobiology, but at the same time, because we are ecologists, we realized that because these landscapes are cultural landscapes shaped both by nature and humans, usually with high nature conservation value, again, the topics approached each other. So because these are cultural landscapes, understanding of local processes, drivers of these processes, both natural and anthropogenic, was our interest. And we approached this by interviewing people and by participatory field work. So spending weeks and months in these landscapes and learning ecology from the locals, and parallelly making quadrats, botanical quadrats, measurements. So we did some ecological research as well. And after this Carpathian case study, we also started another one in the lowlands, what I know more, the Hortobágy National Park, which is a 100,000 hectare large one-piece grassland with marshes. And we worked with herders there, and again, looking not only which species they know, but also which species they don't know. And if they don't know a species, how they relate to known species. Again, the habitats, what they know. And again, the ecological processes they manage, they recognize, they manage, and the conservation consequences and relevance of this knowledge.
I remember hearing at one stage that in traditional ecological knowledge, the way in which landscapes and animals and plants are classified tends to be more specific than in the scientific realm, right? And you just gave a good example now, 148 vegetation types or habitat types in a single valley. That's pretty detailed. But is that also the case when you're looking at different kinds of animals and plants, that they will sort of take what we would regard in the scientific world as one species and divide it up into smaller units?
Classification under the species level is usually done with domestic species, like beans and corns and cassava and the others. With wild animals, it's much rarely happens. We have one interesting story, which is a pan-European story, that the hedgehog is actually two species, two folk species, the dog and the pig hedgehog. And one of them is edible and the other is not edible. And you have to look at the nose and the sound. And actually, we don't know how they distinguish or why they distinguish, because there's only one species. But usually people don't distinguish wild species under the species level. One other example is the grass Alopeculus pratensis, which is totally green in spring and autumn, but it's totally dry like a straw in summer. And you can imagine that the palatability changes. So at least some herders have two different words, but they know that this is the same species. So taxonomically, they regard it as one species, but they have a separate name for the different stages. So what is interesting in folk taxonomy is not simply how many species they know or how many habitats, but what are the indicators they use to distinguish these species, and what are the key features of these species. For example, I remember that some of the weed species, what botanists do not regard anyhow, like Polygonum aviculare and Convolvulus arvensis, these are key forage species in the middle of the summer in drought. And the conservation relevance of this is that in the Hortobágy National Park, if you have a grassland, that dries out by July and August, if you have arable fields, stubble fields nearby, then you can move the animals from the grassland to the arable land to feed on these weeds. And with this, you can decrease the grazing pressure in the protected grasslands. So there are many such differences in emphasis, how they value species, and these differences impact how they manage the resources, and this has an impact how we should manage the protected areas better.
There were two main questions that I wanted to ask. One of them is about the vetting process of TEK. In the scientific realm, we have the peer review process and the scientific method. So my one question was, how can traditional ecological knowledge be considered alongside scientific knowledge, for example, in global assessments, which is now being done, if it doesn't have a comparable process to the peer review process? And I'm making the assumption that it doesn't have a comparable process. Perhaps it does, but I invite you to.
But it does. Okay, yeah. Okay. Yeah. We call it validation of knowledge. And, starting from far, traditional knowledge has a validation process because those groups of people who have wrong knowledge die out. They don't survive anymore. If a scientist produces something which is peer-reviewed, but it's not truth, then he will not die or she will not die. So the validation is more practical in traditional ecological knowledge. It is a practice-oriented knowledge, so it is tested through practice, very often for decades or even centuries. So if we want to decipher how certain natural resource management practice developed and what knowledge it is based on, then we easily end up with an evolution of knowledge for centuries. For example, in the mountains of the Carpathians, people manage grasslands. The livestock spends 7 months in the stable, so they need a lot of hay and good quality hay. And they collect hay seed in the barn, which is a fallen material from the hay. When they are moving the hay in the barn, the dust, broken leaves, and also seeds fall out from the hay. They collect this, and we had a greenhouse experiment that in 1 liter, there is more than 10,000 viable seeds of more than 50 species. And people collect hundreds of kilograms of such hayseed and spread on the grasslands. So they reseed the grasslands with the same material. And these grasslands are among the most biodiverse grasslands in Europe. They are less than 300 years old because they were developed on the former forest. So people manage these grasslands and increase the biodiversity incredibly. And I cannot imagine that you can invent this in a day or in a year. So there must be a very long process of understanding. They distinguish, for example, 2 types of species. One regenerates from roots, and the other regenerates from seeds. So when they manage the parcels, they start mowing every year in a different parcel to let seeds ripen in all parcels in one of the years in this rotation. So you can imagine that this knowledge cannot come from yesterday. So this is the validation, how they validate knowledge. So this is not simply peer review that I write something and somebody reads it and checks it, but it is validated by life. And this is very different from science, but it's not very different from many processes in science because they are testing, they are inventing, they even have hypotheses, they have experiments. There are other people in the community who judge this process, who validate how successful you are. And these interpersonal processes of validations are actually acting very similarly to science. I usually don't validate a scientist by just simply reading the papers. I want to have a coffee with him or her, and spend a week in the field together. So how we validate others' knowledge is not simply peer reviewing, but it's a much more complex process even in science. And if you go back to conservation, whatever peer-reviewed literature you have, if it doesn't work in the field, then it's not a useful knowledge on that place. So to validate conservation biological knowledge, you have nature and you have the conservation management, and that validates our understanding of our knowledge. For example, in IBES, in the Intergovernmental Panel for Biodiversity and Ecosystem Services, we had some discussions on how to validate traditional knowledge and cross-validation with science, the ethical issues of this cross-validation. So I went to the herders and asked, how do you validate the knowledge of your friend? And he said that, oh, I look at his sheep. The sheep validates his knowledge. Whatever he speaks, it doesn't matter. Look at his sheep. That shows the story. And if you go to Mongolia or to Iran, to other countries, you get the same answer. So a Mongolian herder validates the knowledge of another herder by looking at the animals. Very strong validation method. And for the IVETs, we made a film and we had a question to the herder. So how you cooperate with scientists and how you validate each other. And I would like to read these sentences, what he answered to this question. He said that cooperating with scientists, that was the topic. So we need to recognize each other's knowledge. Then researchers have to try living together with the herder to understand why we do the things we do and to realize that it is really a sort of science. And a herder has to recognize the researcher's knowledge as valid too. So cross-validation is not simply from our side, but it's not easy from the herder's side either.
These are quite interesting examples and very practical, right? They're very management oriented. One bit of pushback that I want to give is actually not management related, but more perhaps more on the taxonomic side. Earlier on, you made those two distinctions, right? There's a more management oriented TEK and the more classification oriented TEK. So I guess this question is more about the classification side of things. But the broader question is, what about cases where traditional ecological knowledge is demonstrably incorrect? And one example that I can think of from my own experience is when I was younger, I was very into reptiles and snakes in particular. And some of the local communities believed that certain snake and lizard species were venomous and deadly, poisonous. So they wouldn't touch them because they thought that they'd be killed if they did. And it's quite well known that they're not. I've handled these creatures. I've even been bitten by them, so I can prove that they're not.
This is a very interesting, very important, and a challenging question. So TEK is adaptive, which means that if the environment changes and the society changes, then the TEK adapts. Why it needs to adapt? Because it is becoming irrelevant. We can say it became wrong to answer that question, to answer that change. So TEK is always wrong in that sense that it always needs adaptation to the changes. And locals exactly know that they have to adapt. So if a scientist describes a management practice before its adaptation, it's easy to show that it's wrong because not yet adapted to the new changes. And we have many situations that the changes are too fast and traditional knowledge needs time to adapt. So there is a mismatch in the speed of changes. This is one issue. The other issue is that if there is a driver, outside driver, then the locals realize that they are doing something bad. So if you describe the process of the practice, if you describe the practice itself, it is destructing nature, it is unsustainable. If you ask the locals why they do it, then they list external pressures. So they exactly know that their knowledge, their practice is wrong at the moment, but they are forced because they have children who go to school, they need cash. So there are constraints. And if a scientist only describes the practice itself without the background information, what locals think about this practice, you can easily say that, the local knowledge is wrong. Another issue is when, your snake example, it is safer to be aware of all snakes than to teach your child which one is venomous and which one is not. So this is practical knowledge. So even if they know, some of the old, very clever members of the society know that some of these snakes are not venomous, for safety, they keep it in the group of venomous snakes because it's vital. And then finally, simply it becomes a venomous snake for the locals because it's safe. There are other cases when the scientist is not able to understand the real meaning of local knowledge and local practices because the scientist is working too long term, too short term. So the scientists focus on different aspects of nature. And then there's a mismatch in simply understanding why locals argue that this is the truth, because it's not the truth. And maybe the last answer to your question is that, for example, the migratory birds issue and the mushroom rings, the fairy rings of mushrooms. So these are ecological phenomena that cannot be decoded by the locals. So locals do not travel to Africa to monitor the migration of birds, but they want to explain where those birds gone. Because the children ask, "Father, where are the storks gone?" And then you have to answer something, and you have a fairy tale or you have a rational argument, but there's a need to explain everything. And that's how science works. We also have many explanations, especially conservation needs explanation for everything. So many of our explanations will turn out wrong after more research. And the fairy rings, for example, the spores of the mushrooms cannot be seen by the locals, and they don't know the hypha system and how mushrooms grow under the surface. So they invent explanation. But if you ask herders who are knowledgeable and live for the long term in the same pasture, then they realize that some of these rings increase. So they have some understanding, but they cannot decode the real cause of the system. And then they invent something, and then it's easy to say that, oh, they are just wrong with the explanation. But they don't have the method to learn.
Have you come across any examples where there's just a straightforward conflict between the scientific answer to a question and the TEK answer to a question?
Surely there are some, and without really knowing the situation locally, it's not easy to make a judgment or to validate which argument is better. There are very good examples on the western coast of Canada, on the beluga and the whale population dynamics, where science and local knowledge was contradicting. And then after 5, 10, 20 years of research, the problem was resolved, and sometimes science, sometimes local knowledge was more closer to the consensus after 20 years of research. Mm-hmm. Because I started as an ecologist and not as a social scientist, I'm more interested in what we can learn from the values and from the perspectives of how local knowledge holders view nature. So, for example, in nature conservation, if you want to manage a pasture only for biodiversity and all your management decisions focus on the protected and threatened animals and plants, and you forgot that to have proper grazing on that land, you need proper livestock that knows how to graze on that land, and you know the people who know these livestock and know the pasture and know how to manage the livestock. Recently, last year, we published a paper on how efficiently herders motivate livestock to eat up certain species or eat in certain patches of the pasture, which has serious conservation consequences. Many of them are positive, but some are negative. So if you only focus on the protected species, you lose the understanding of the system. We can call it a contradiction that conservation biologists tend to focus mostly on biological issues, and the herder has a more complex understanding of the system. But as you see the history of conservation biology, it is becoming more and more interested in social issues, in human perceptions. So conservation biology as a practical science is actually moving much quicker towards understanding complex social ecological systems than ecology itself, because ecologists are happy with the pure ecological questions. There are many unresolved questions in ecology, but the conservation biologist moves toward a more complex understanding of the system, and that's what we learn from traditional knowledge. So I don't focus exactly, they mistake this species with that species. It doesn't really matter, because if they understand the functioning of the system, it doesn't really matter how many species you base your knowledge on. Yeah, that's my short answer to science and local knowledge can work together. And to speak on from the other side, herders often become frustrated about conservation of species that are very common in their pastures. Why you focus on that species? And we have to help them to understand that species is endemic, only occurs in this part of the world, or this is a migratory bird and it spends the autumn in this landscape and then migrates to Africa. And we have to protect this bird in October, in November, in this place. And herders are very happy when they understand why a conservationist acts differently than he would expect, because they are eager to learn, but it's very difficult for them to understand those processes that they have never experienced.
That actually brings us very neatly to the other major question that I had, which was about the local nature of indigenous and local knowledge, or traditional ecological knowledge. So again, looking at global assessments and regional assessments like EPBES, which we were both involved in, what I'm wondering is, how can TEK be regarded as one thing when it's lots of different things in different places and different parts of the world, without very much communication with each other, at least at particular points in time? So why is it legitimate to consider ILK or TEK to be a unified concept, to talk about it as a unified concept? And how can it be universally applied if the lessons are so locally oriented and so locally specific?
In my understanding, indigenous and local knowledge is very diverse. The cultures of the knowledge holders is very diverse. So I don't think it's a unified concept. It's easy to speak with these TEK, ILK. It's easy to group all these different knowledges into one concept. And it might help for some time. But as soon as we realize the importance of these local knowledges and local understandings in solving global problems, then we will become more diverse in our communications. There isn't even a definition for indigenous and local knowledge in an Aristotelian way, because we focus on knowledge that is not coming from science. We are focusing on knowledge and practices and worldviews that come from that place, that are long-term, that are transmitted through many generations, that are tested locally, validated locally, which is different from science, but not as different as often we argue. So the local you go, the closer science and local knowledge can come. The global you go, again, some arguments can approach each other or get close to each other. There are some issues where science and local knowledge is very different. So we can focus on those, especially worldview elements that are very different. But I would not call it a unified concept, and I would not make an opposition between science and indigenous knowledge. I would focus on the possibilities of cooperations and knowledge co-production, as we say, when we sit together at a table and bring onto the table scientific knowledge and local traditional knowledge. and then try to solve the problem. And knowledge co-production means that some new knowledge is developing around the table because different arguments and evidences are brought together, wean into each other, and then a new understanding comes. So I would focus more on this. But back to the universality of the knowledge. Just to give you some examples, I mentioned the Hortobágy National Park with the herders. There's a grass called Festuca pseudovina, fescue. It's a small tussocky grass in dry or drier places. And if you ask herders about this small but common species, then they answer that, oh, Zsolt, this is the soul of Hortobágy. This is the first grass in our pasture. And in vegetation science and in grassland science, it is a third category grass because it's small and the production per hectare is small. But if you ask a herder, this is the soul of the Hortobágy. This is local knowledge. Okay. Then you go to Mongolia, visit herders in Mongolia, and ask one of our friends, Irdincokt, to group species. So we brought about 40, 50 species. And in the yurt, we asked him to group these species. So Irdincokt grouped them into palatable, non-palatable, spring species, autumn species, wetland species, forest species, into male and female plants, and so on and so on. And after half an hour, he grabbed the photo of Festuca, which is botyul in Mongolian. He lifted the sheet in a very ceremonial way. He said, and this is the botyul. And he put the sheet on the top of all the groups he made in the previous half an hour. And the neighbor herder said that, yes, this is the best grass in Mongolia, what my livestock can feed on. So the same genus, Festuca, fescue, in Mongolia, in Hungary, this is the first grass. This is an example how non-local traditional knowledge can be. And if we continue just this story, when we ask these herders, how do you know these plants? They answer in Mongolia, in Hungary, but also in Kenya with the same sentence. I know the species through the mouth of my animals. This is what they say in Kenya, in Mongolia, in Hungary. So is it universal knowledge or local? And Darrell Posey, who was an ethnobiologist, actually founded the International Society of Ethnobiology. He worked in the Amazon, and he said that local knowledge is actually not local. It is the local version of a universal knowledge. And that's why IBES is able to use this understanding of nature, because some of these local understandings are really universal. And how people should manage and care for natural resources has many universal elements in different cultures. And some of these universal elements are very different from the scientific understanding of nature and ecosystem services, how we called them. So this is the local and universal gradient of traditional knowledge.
On a similar topic, I was working in the arid western part of South Africa, and most of my work was involving ecological surveys of that area and other parts of South Africa. But I also had the chance to interview about 20 farmers in the area, and there were two species that over the decades and the centuries that they and their fathers and their fathers had been on the land, two species that had slowly come into the area and two other species which had slowly exited the area. One of them was actually the Southern African hedgehog. You were talking about hedgehogs earlier on. But what was interesting was these farmers were all more or less a patchwork. And the farmers in the southwest, the last time they saw a hedgehog was when their great-grandfather was there. But the ones in the northeast, it was their fathers, or in some cases themselves, who had seen this species. And another little anecdote, just for your interest, another part of South Africa, also quite arid actually, part of the Karoo. I worked with a bunch of guys who, they were quite old and they had spent their whole lives on the land, but they were basically first generation in that area. And the rainfall there is about 250 millimeters a year, pretty scarce. And one weekend we had 200 milliliters, so almost the entire year's rainfall was in a few days. It was an incredible sight. So that's another story. But after the day after the rain, suddenly there were these giant earthworms all over the place, and this is possibly the largest species in the world. But anyway, these guys had never seen these things before. And the reason was because they had never had rain like that before. That was the first time that there had been, well, the first time in at least 50 years that there had been that kind of rain. So that just shows how important generational knowledge is, passing on from one to another. They knew all sorts of things about the year to year and decade to decade changes that happened there, but they couldn't tell you anything about the century to century changes because there had been that disconnection.
That reminds me what a local knowledge holder can get from science. One of the herders told me that, Zsolt, you helped me to understand why my father was right in this or that question, because I had no possibility to check his understanding of that phenomena. I never experienced that, but because you read other literatures, you gave me examples that coincide with what my father told me. So you had me respect even more my father's knowledge because I was skeptical with his knowledge because I couldn't find the evidence for that, but you helped me to find the evidence. So this is, again, a very nice intergenerational knowledge transfer. Then, what I read was collected by ethnographers from herders in the 19th century. So actually, the science was the agent to transmit traditional knowledge to a traditional knowledge holders who lives 100 years later. So this is really interesting how these two knowledge systems cooperate.